All right, here we are, problem 19 on page 219. This is a problem about polynomial inequalities, and this is meant to help you out with homework 12, which comprises, among other problems, problem 18 on page 219, I believe. Let's do this problem. I love polynomial inequalities because they are much easier to complete than you might imagine. All you have to do really is to look at this polynomial function over here that is factored, and you can very quickly see the zeros of this polynomial, right? They are x is equal to 5. If x equals 5, this term is 0, so the whole thing is 0. And they are x equals minus 2. And furthermore, you have to take note that x plus 2 is a factor that appears once, and therefore this root has multiplicity 1. X minus 5 is a factor that appears twice. That squared exponent takes care of that, and therefore it has a multiplicity of 2. So I just have to make a little skeleton graph here, and I'm going to graph these zeros. There is the point 5, 0, 1, 2, 3, 4, and 5 right there. 5, 0. And I'm going to plot this point minus 2, 0. Now what's special about these points is the function touches or crosses the x-axis at these points. So, and in fact, we know that the function is going to touch over here where the multiplicity is 2, and it's going to cross over here where the multiplicity is 1. So indeed, both of these points are on the curve, and the curve is either touching here, touching in that manner, crossing in that manner, crossing in that manner. And all you really have to do is pick a number, any number. Let's take x equals 0, and let's note that if x is equal to 0, this quantity x minus 5 squared, x plus 2 squared is then equal to minus 5 squared is 25 times 2 is 50. Most importantly, it's positive, right? So if we were to plot the point that's on the curve, we would go 0, 50. But all I really need to do is to note that in this region, this function is positive. And it stays positive until it has a chance to cross the x-axis. So it's positive throughout this whole region, and by virtue of the fact that it touches here and doesn't cross, it's positive in this region as well. It doesn't go negative until it reaches this point. So for these values of x, the function is positive, and since the function crosses the axis here, for these values of x, and these values are the values of x between minus infinity and minus 2, for all of those values, this function is negative. And in fact, that's exactly what we're looking for. We're looking for the values of x that make this negative. And so the answer to this question is it's the set of all x such that x is a member of minus infinity to minus 2.